Hello, my name is Dan Nissen, and today we'll be looking at AOVs inside of Redshift for Cinema 4D. I will show you how to render these passes, as well as quickly comping them inside of Photoshop. We will break down the new custom AOV features, and the many ways we can write our own specific AOVs. We will also be taking a look at some of the other AOV choices that will make comping our images a lot easier. Alright, let's get started. Alright, as you can see, I've prepared a scene for us today that is composed of a lot of different elements, which is going to help us when taking a look at AOVs inside of Redshift. Now, AOV stands for Arbitrary Output Variables, and these are passes that are rendered alongside our final beauty. Now, we're going to be taking a look at what I refer to as the standard AOVs first, and these are the AOVs that basically make up our beauty. So let's go ahead and hide this for now. And let's go to our render settings under Redshift, and let's go to our AOV tab. And as you can see, we can quickly start adding any AOVs we want. And as we start expanding these different settings, you can see it starts getting cluttered very quickly and quite confusing. So we're going to open up the AOV manager, which I suggest always using this when dealing with AOVs. And this is basically a much easier way to add and delete our AOVs, and a better way to manage them as well, hence the name AOV Manager. And before I actually get into the actual AOVs themselves, I want to note that I'm not going to be covering each and every individual AOV, as I won't have time today. But if you go on the Redshift docs, they actually have a brief description for every single AOV here, if you're ever confused. And I'm also not going to be going over the raw AOVs today, which is basically, it's even more control if you need it. So for example, or what I mean by that is if we take the diffuse lighting into here, the diffuse lighting is actually made up of the diffuse lighting raw with the diffuse filter multiplied over the top. And you would be doing that math inside of Photoshop, Fusion, Nuke, whatever you're using. And I've personally never had to use those, but if you do need that extra control, it is there for you. And once again, if it's not very clear to you, you can go on the Redshift docs and they cover that as well. So let's actually look at our settings for our AOVs. Now we have an option to enable or disable it from being rendered. We can actually change the AOV that's being outputted, but we want diffuse lighting. We can also rename it if we do need to, but I like keeping the default names for the most part. And actually a setting that we need to pay close attention to is the apply color processing. And we're actually going to be disabling this for every single AOV. And what this is doing is if we go to our camera and go to our camera tag, this is actually disabling all these settings, the tone mapping and exposure settings, from being applied to our AOV. And I don't have these on anyways, but we want to make sure we're disabling these because it can lead to issues inside of post. So we're going to make sure we're always disabling this for every single AOV. We're going to keep multipass output enabled, and we're going to make sure we're rendering out at 32-bit. Now, we won't be using the direct output settings today, and basically what these are is if you need to change the individual settings for every AOV. So say what I mean by that is, say we want to render this AOV as a PNG instead of an EXR, we have the ability to, but we're not going to be needing that because we're using multipass output. So all these AOVs are going to be included inside of one single EXR image. So let's go ahead and take a look at our scene again, and let's see what AOVs we're going to be needing to rebuild our beauty. So as you can see, we have subsurface scattering, we have emission, we have refractive materials. So we're gonna need to be including all these AOVs in our list to render out and then later rebuild inside of Photoshop. So let's go ahead and hide this again, and let's start dragging and dropping these AOVs that we're gonna be needing. So we have caustics in our scene, we have emission in our scene, we have GI enabled, we have reflections, we have refractions, we have specular lighting, we have subsurface scattering, and we have volume lighting. And once again, I'm going to be disabling apply color processing on each one. And the way you're adding these AOVs, it's based off your own scene. So if your scene doesn't have subsurface scattering, then you don't need a subsurface scattering AOV. But at the same time, you need to make sure that you're including every single part that is making up your beauty. Because the whole point of AOVs is to save you in the long run. It's kind of like insurance, to tweak certain elements in your scene later in post. And if you're forgetting AOVs, you're defeating the entire purpose of them, of saving you time if you have to go back and re-render them. Especially if you're working with a compositor, you don't want to put more stress on him by not including AOVs that you actually need. So what we're going to do now is we're actually going to render these out so we can take a look at them. And the way we do that is we go back to our render view, and we need to render this out in bucket mode, as the AOVs won't be displayed in progressive mode. So let's go ahead and do that and take a look after this is done rendering. So now that it's finished rendering, let's take a look at our AOVs. So if we go to our drop down menu here, you can see all our AOVs rendered out, and we're going to be using the arrow keys to cycle through them. So we have our beauty as before, but now we have a few more passes. So we have our caustics, our diffuse lighting, our emission, our GI, our reflections, refractions, subsurface scattering, specular lighting, and our volume lighting. And these are all the passes we need to rebuild our beauty inside of Photoshop, which we're going to be doing that a little bit later. For right now, we're going to look at some more AOV options inside of Redshift. So let's go ahead and hide this for now, and let's go back to our AOV manager. Now say we want to create a global ambient occlusion pass for our entire scene. Well, you might say, let's just drag in the ambient occlusion AOV into our AOV list. Well, this AOV actually only accounts for the ambient occlusion in our shaders. This won't be a global ambient occlusion pass. So we don't have any ambient occlusion in our shaders, so this AOV is going to render out blank, or it's just going to render out black. So what we actually want to do is create a custom AOV. Now you might have noticed when I dragged in this custom AOV, the custom AOV option in our left-hand column is still there. This basically means we can create as many custom AOVs as we want. You also might have noticed earlier when we dragged in our diffuse lighting, caustics, etc. Basically our AOVs 1 through 9, they actually disappeared from this list on the left. This basically means that we can only have one instance of this AOV rendered out. So let's take a look at our custom AOV options. So it has the same exact settings as a regular AOV, except it has a default material slot, which is basically going to be a global override for our AOV container, which will make more sense once I demonstrate this. But for right now, let's go ahead and hide this, and let's create a new material. Now, thankfully, Redshift has already set up a ambient occlusion node setup for us to be easily used with custom AOVs. So if we go to Utilities and AO, you can see our new material created, and let's go to the shader graph. And as you can see, this is a regular ambient occlusion node connected to the output. Now we actually can write any data we want to this AOV. So for example, if we wanted to write a global curvature map to everything in the scene, a texture, if we want to write a texture to every object in our scene, let's go to utilities. If we want to create a Fresnel curve for everything in our scene, we can render these out as a custom AOV. The only thing you can't write to custom AOVs is shaders, so you can't write anything under this materials categories to our custom AOV. This is an illegal operation inside of Redshift. It won't work, and I believe that's how it is for most render engines. So let's actually take a look at our Redshift ambient occlusion, and we're going to keep all these settings default, and we're just going to raise the samples to 64. Now let's go ahead and close this. And we actually can rename this material just to stay organized to, let's do custom AO1. And then once again, the name doesn't really matter. It's, whatever your naming conventions are. So let's go back to our AOV manager. And what we want to do is we want to drag our newly built material, our custom AO1, into the default material slot. So basically what this is going to be doing is the settings we set up, which we kept at default in this custom AO1, it's going to be applying this ambient occlusion shader to our entire scene, but it's not going to be affecting our beauty at all. This is a custom AOV. So let's go ahead and rename this to AO custom 1. And once again, make sure apply color processing is disabled. And we're going to render this out in the render viewer. Once again, remember, in bucket mode. And after this is finished rendering, we'll take a look at it. Okay, now that it's finished rendering, let's take a look. Now remember, if we look at our AOV manager, we named this custom AOV AO custom 1. So when we go to our render view, we can see AO custom 1. And as you can see, we successfully set up a custom AOV, which is applying a global ambient occlusion to all the objects in our scene. Now, say we want to take this a step further and we want to exclude certain materials from receiving this ambient occlusion. Well, we can easily do that with the store color node inside of the shader graph. So let's go ahead and hide these for now. And say we want to stop our emissive sphere from receiving this ambient occlusion. Well, we can easily do that. We go to the shader graph, and we're going to look at our AOV nodes. Now, we're just going to be using the store color to AOV node today, as most of the changes we'll be making in post is slight hue and saturation changes and maybe some lighting adjustments, but we won't be needing any integer or scalar data today. So the way this store color to AOV node works is it's like a buffer between the output and the material. So we're going to connect our material to the beauty input and then connect this to the output. And now we can start writing data on top of AOVs. So what I mean by that is if we go and find our AO custom 1, which we want to exclude certain shaders from receiving this ambient occlusion, so we make sure we click on AO custom 1, and the way these ambient occlusion maps work is you use them to multiply over the top of things. So basically what we want to do is to exclude certain things from this ambient occlusion, we want to make them pure 255 white. So when we go to multiply them, it's not having any effect on those parts of the AOV, which it will make more sense once you see it inside of the render view. So that's all we have to do to write over the top of this AO custom 1. And the way this works is it's adding over the top. It's adding this white 255 over the top. So let's go ahead and add this to one more material. Let's do our water material just because it's so easy to set up. So store color to AOV, connect this to the beauty, connect this to the output. Once again, we're writing over AO custom 1. And we're writing 255 white, so nothing is being multiplied when we go to into Photoshop. Now let's go back to our render view, and we're gonna re-render this out to see how it's affecting AO custom 1. And once again, remember we have to do a bucket render as they're not displayed in progressive mode. Alright, now let's look at our AO custom 1 to see what's changed. As you can see, our emissive sphere is no longer receiving ambient occlusion, as well as our water bubbles up in the top left are not receiving ambient occlusion. Now remember, we just wrote custom AOV data for our one water material, but because all these objects that are bubbles are sharing the same material, they're all being affected. And everything I've showed you so far is on a per material basis, and later we'll be looking at writing custom AOVs on a per object basis. So for right now, let's actually go ahead and create a new custom AOV, and we're going to be creating a custom AOV for our Redshift logo. So let's go ahead and hide this, and let's actually open up our logo shader graph. Now once again, we're going to be adding the store color to AOV, plugging the material into the beauty input, plugging this into the output, and we actually can create a new custom AOV from this menu. So we're going to do add new custom AOV, and we're going to call this RS logo 1. And OK. And now what we actually want to do is, so we have our Redshift logo texture, and we actually want to write the alpha out to our AOV. So we're going to plug this into AOV input 0. So we're just getting the alpha included in this AOV and not the entire object. So now what we're going to do is we're going to render this out to see how it looks. And if we go to our AOV manager, as you can see, we have our Redshift logo 1, the custom AOV that we just created. Make sure apply color processing is not enabled. And we don't need a default material applied here because this is just on a per material basis. This is not a global shader. So let's go ahead and go to the render view and render this out to see how it's looking. Alright, so let's look at our newest custom AOV. And remember, we named this RS logo 1. So when we go to our AOV drop-down menu, we can see RS logo 1. And we have successfully written out a custom AOV just for our Redshift logo on our object. Now, I've been showing you how to write custom AOVs based off the materials in our scene. And now I'm going to show you how to write custom AOVs based off the objects in our scene. And we're going to be using user data to do this. Now, before I start, I have to give a huge shout out to Adrian off of the Redshift forums. I'm sure if you've ever asked a question on there, he's the first one to answer. Really helpful guy. And he's the first one that exposed this technique to me, so big shout outs to him. I'm really appreciative of it. So let's go ahead and hide this for now, and let's create a new custom AOV. So we're going to name this user data custom. Remember, the name doesn't really matter, but we want to try to stay as organized as possible. And let's go ahead and create a new material and open up the shader graph. And remember, we cannot write materials to custom AOVs, so we're going to go ahead and delete this. And we're going to bring in a shader switch and connect this to the output. And we're also going to need an integer user data node. And we're going to plug this into our selector for our shader switch. And I'll be explaining this setup in a little bit, but first let's start assigning user data to objects in our scene. So say let's add, we want to add user data to our figure object. So we can go to user data, add user data. And first what we want to do is change the data type to integer. And we're also going to rename this to user data rs1. And we'll be needing to remember this name for our shader setup that I showed you earlier, but we can always come back to it if we do forget it. So let's go ahead and hit OK. And let's actually go back to our material, and we can actually rename this as well. Let's rename this to user data 1, and let's open up the shader graph again. Now, remember, we need to use that name that we set up for the user data, so we can actually go back to the figure, and we can go to manage user data. We can actually copy and paste this name with Control C, and then paste this here. Control V, so we make sure that we don't misspell anything. And also what we want to do is back on our figure where we set up the user data, we actually want to set this to 1. And I'll explain why in a second. So if we go back to our shader graph in our material that we created for user data 1, the default set at 0, so we go into our shader switch, we actually want to set the shader 0 color to black. And we want to make sure that we're setting shader 1 color to white. So everything with user data that is set to 1 is going to render white. Everything else is going to render black. So let's add a few more objects before we render so I can show this effect. So let's go ahead and hide this. And let's just start adding this user data to other objects. And what we can actually do is we can copy and paste this user data to make it a lot quicker. So if we go to manage user data on our figure, and we can right click this user data rs1, copy. And now let's add this to our blue donut here. So we'll go to user data tab and then paste user data interface. Make sure the settings are all good. Yep, and hit OK. And then we're going to change this to 1, remember? And then let's add this to one of the bubbles in our top left hand corner. And remember, once again, we're going to user data, paste user data interface, make sure the settings are all good. Yep. And we're going to set this to 1. Remember, this is writing a custom AOV based off the objects in our scene, not the materials. So now what we want to do is we want to go back to our custom AOVs, and we actually want to drop this material into the default material slot for our user data custom. So we'll drop this into here, and make sure, once again, apply color processing is disabled, and leave everything else the same. And let's render this out to see what is going on. Alright, let's take a look at our latest custom AOV. So if we scroll down and look at the user data custom, you can see that we're getting the expected results. All of the objects that we applied user data to and set the integer to 1 is rendering out white. Now you might have noticed that our blue torus that we applied user data to, I'll go back to the beauty, is actually being intersected by a refractive material. Now if we look at the custom AOV we created, it's not taking that into consideration. So if we were to use this to adjust the color inside of Photoshop, we'd run into some issues because it'd only be adjusting the parts that are not being refracted. So if we were going to change the color to red, the refracted part would still be blue, which would obviously be trouble for us. So there is a way to work around this, and it's actually the next AOV that we're going to be looking at. So let's go ahead and close this for now, and let's take a look at the puzzle mat. And remember, I talked about this earlier. We can add as many as we want, but it is limited to 3 sets of selections. And what I mean by that is it's limited to red, green, and blue values. Now, basically, let's go ahead and look at the settings before I get into it real quick. So we're going to switch the mode to Object ID, and we're going to change the red ID to 1, green ID to 2, and you guessed it, blue ID to 3. Now with these settings right here, depending on which objects we assign which IDs to, we're going to get pure red, green, and blue values. Now say we tick on the reflect/refract IDs options, which we are for this puzzle mat. Now what this is going to do is it's going to take multiple objects into consideration for the final color. And what I mean by that is it's going to take reflection and refractions into consideration for the colors. So you might not get pure red, green, and blue values anymore. You might get some magentas, some yellows, some pinks, whatever it is, out of our final puzzle map. And this will make more sense once we render it out and view it in the render view, and make even more sense once we use it inside of Photoshop. And the reason that this AOV is so useful inside of Photoshop is you can take the pure red, green, and blue channels from an image and use them as masks inside of Photoshop. And that's why it's so useful inside of there. And once again, it'll make more sense once we're inside of Photoshop and you can actually visualize it. So let's actually go ahead and let's move this over. And let's start adding Redshift object IDs to different objects. So let's actually take our, let's add to our backdrop. So let's right click this, go to Redshift tags and Redshift object tag. And let's change the object ID. So we're going to override and we're going to put the object ID to 1. So basically this is assigning the red to this backdrop. And we're only going to, because we want to isolate the backdrop from everything else, so we're just going to include this to the red ID 1. So next, let's actually add our blue torus that I was talking about that was having the refractive issues. Let's add a Redshift tag, object tag, override, and we're going to make this ID 2 for the green. Now, once again, we're not going to get a pure green value anymore because it's taking into consideration for the reflections and the refractions. And we'll be able to view that inside the render view in a little bit. And now let's add a couple objects to our blue ID 3. So let's just add our pyramid. And we'll override this to 3. And let's add our Redshift logo as well. just so we can view this effect. And actually, let's add one more. We'll add our metal sphere as well. And we'll set this to object ID 3. Now we're actually going to, once again, remember, we're rendering out at 32-bit. And let's actually go to our render view. And let's render this out, remember, in bucket mode. And see what this is doing. Alright, now let's take a look at our puzzle map before we hop into Photoshop. So if we go to our AOV list and go to puzzle map, you can see this is the result that we're getting. Remember, we assigned our backdrop to the red channel. And as you can see, what I mean by the reflect/refract option that we enabled. As you can see in our sphere that is very reflective, we're getting a kind of a pink color. And if we bring up our actual pixel values, you can see here it's almost like a magenta because it's reflecting that red background, but it's, you know, it's not going to be a pure red reflection of it, so it's going to be coming out magenta, and that's what I was talking about earlier. Also, you can see these objects that we applied the blue ID, which was 3 to. The edges where it's more reflective, as you can see, it's getting like a more magenta. And once again, remember the green ID 2, which we applied to the torus, we're now getting that refractiveness coming through, which is going to be very helpful when adjusting this torus inside of Photoshop. Now let's actually hop into Photoshop so I can properly show you how to use this pass. Also, I'm going to show you how I save this out really quickly. So if we go to File, Save Multi-Layer EXR As, and I have it here as AOV_tuts, and we're going to save this here. And basically what this is going to be doing is saving our beauty plus all our AOVs as layer in a single EXR image that we can open up inside of Photoshop.